If you remember, we saw the characterization of the differentiability of function. We said that f is differentiable at x0. We saw the following characterization: if and only if that fx, you can write it as an fx0 plus x minus x0 f prime at x0 plus, so function epsilon, we said an h is here x minus x0, so it's so x minus x0 epsilon at x minus x0 with, we said, with the limit of the function epsilon x minus x0 as x approaches x0 equal 0. Okay, so the fact, so let's call, or the fact that this quantity, is goes to 0, that means we can approach the value of f by this quantity. Okay, so we will set, by definition, we will set the following definition. Okay, definition. So we will call, let's call that Lx. We call, so we call linear the function that x assigned Lx, okay, equal fx0 plus f prime x0 times x minus x0, the linear approximation, linear because this is a constant, this is a linear term with degree 1 in x, and this is a constant. The value of the derivative at x0 is a constant. So we have a linear expression. So we can here, so we are approaching an f by this linear part since this quantity approaches 0. So the linear approximation of f at x0. Okay, and we say, yes, that we denote, okay, that fx, we say that fx, we can approach it at in neighborhood of x0, okay, for an x close to x0 by this expression Lx. Okay, we can use this approximation. We have, of course, this is an approximation, so that means it's not the exact value. It doesn't substitute the exact value to f, but it's an approximation. So the difference, if we call e of x, let's continue like add this as a definition. Let's include this in the definition. Okay, so ax, the difference in absolute value, fx minus lx, is the error measures, or is the error of the approximation. Okay, so this is the difference between the exact value and the approximate value at x. So let's do a first example. Okay, an example. So we will do a direct application of the definition, linear approximation for the function square root of x plus 3. we are asked to find the linear approximation of f at 1. So the linear approximation of f at 1. So we know that so this is the first thing we are looking for. So we know that it is given by Lx equal f1 plus f prime at 1 and x minus 1, or x0 here is 1. Okay, so we will need the derivative of f. So let's compute f prime. We know it's 1 over 2 square root of x plus 3. Okay, so f prime 1. So f1 we will substitute, it will be 4 square root of 4 plus f prime 1 over 2 square root of 4 x minus 1, which is then 2 plus 1 over 4 x minus 1. So here is our line. Okay, we are asked to find an approximate value. Use this linear approximation to give an approximate value of 3.980. Okay, so if you look at this quantity, so we can write it as we want to use, of course, the function f. So it's exactly 0.98 plus 3. So I can express it as exactly f0.98. Okay, so we don't, for example, square root of 4, I can have the exact value, but this one I can't easily guess the exact value. So let's use the linear approximation to find an approximate value of this square root. Okay, so since we have to compute this, we know that 0.98 is close to 1. It is close to 1, so I can say it's L at 0.98. Now, if you compute L at 0.98, it gives you 2 plus 1 over 4 of 0.98 minus 1, which is 2 plus 1 over 4 minus 0.02. And if you compute the value, you will get 1995. Similarly, if you are asked to compute approximate value of 405, you can write it as, so it's here 1.05 plus 3. So that means I'm looking for 105, which is, since this value is close to 1, I can use the linear approximation. Okay, and L at 105, okay, is equal to 2 plus 1 over 4, 105 minus 1, which is 2 plus 1 over 4, 005, which gives us 20125. So this is the value, approximate value of square root of 3. It's okay. So this is the approximate value of square root of 398, and this one is the approximate value of square root of 405. Okay. So yes, so this is the main point. Now, last remark, important remark. If you look now, this function L, if you look at its graph, okay, graph of L. So if you look at the graph of L, so it's if you look, this is L, here is Y. If you want to try, So we know that it is the equation of tangent line. So is given is the graph of L is the line the tangent line is the tangent line at x0 to the curve y equal fx. And this makes sense. We know that yes, the tangent line is very close to our function. Okay, so this is the